Okay, let's go back to the example that we started with, which is the mutual fund accounts, and basically these and what did we do? We did the population. Let's say here this is the population distribution. So these are number of the accounts, number of mutual accounts, right? This is for the employee retirement funds for small companies. So these are a number of mutual funds in each client's portfolio, and it contains 200 AIMS customers. So this is my population. So this is my population distribution, right? But suppose that I don't have access to the population. Let's make some connections between the population distribution and the sampling distribution. And this is, I believe, this is the most important video in the whole semester. So you have to understand the difference between the population distribution and the sampling distribution. So because I'm going to show the sampling distribution right now. So this is the population distribution. The values in the x-axis represent number of mutual funds. These are the x values. This is the variable x. This is my random variable. Do you remember that? Random variable x. So all of these represent the x, and all of these represent the frequency, right? So this is my population distribution. Let me just take it to the side. And now let's do something again. Let me create sample of 30. So because there's no time, so I will take sample of 30. Okay, so we're going to pick sample of, okay, 30. That's fine. Is it 30? 30. Again, I'm going to use the same function, index. I will be trying to make it bigger. Okay. Index, sort by, and I'm going to choose B2 up to B2001, 201, I guess. Round array. Again, B2 to B201, right? I keep forgetting the row function, rows, because we need to specify. And sequence. Here we go. This is the first sample. We have sample of 30, okay? So what I'm going to do, let me do this again because I want to fix these numbers or lock them. And I'm going to take, let's say, 100 sample. Okay, 100 sample. I don't want, we can take so many different samples, by the way. We can take so many samples, okay? But I decided to take only 100 because we want to explain, or we want to do the what's so called the sampling distribution. So I'm going to, again, I'm going to copy this, just a drag drop. We got the same idea now. Okay. So we got different samples, 100 different samples. This is nice. I don't want to take, I just don't want to confuse you. So this is my sample size. We have 30. Now, let's do one thing. So let me take this down. So the first thing, let's find the average of the population. Population average. Population average, or the mean, is all of these. 2.5. Let's find the population standard deviation. STDEV dot P, because population. Control Shift down arrow, enter, and we're done. 1.5. So these are fixed. We don't want to forget them. Now, let's find the average of each sample. Average of each sample. Average of each sample. So the average. So let's say average of samples. So all of these, this is the first sample. And I would calculate the averages for all of these samples, right? And what I'm going to do now, I'm going to select all of these, and I'm going to copy them, okay? And I'm going to, okay, let me stay here. I'm going to paste them here, but I'm going to paste the transpose and values. Values, then copy, transpose. I pasted value, then I'm gonna paste transpose. Transpose, just I wanna see them. What are these? These are the averages of the sample. samples, all of these them, right? Now, if I would like to calculate the error, we're gonna find different errors, as we said in the previous, in the previous video, right? But what I'm going to do now, I would like to graph them. Let's say graph these guys. So insert pivot table somewhere here. The averages. Again, this menu averages here. Now, because these are kind of continuous, I'm going to group them. We can do something, but not now. Let me do something before that. Let me go back again. So we learn some of the stuff here. So let me take these numbers, let me averages. I want to just round them, okay? I want to just find the round these guys, round 1 digit. Let's say 2 digits. Yes. Double click, we're done. So I'm going to take these values after rounding. Again, I'm going to pivot table. Just say 1/2, not, or G basically, G. Yep. G, the existing here, average of the samples. So I'm going to take the averages here, then I'm going to group them. Maybe we can make it more specified here. This is smaller groups, that's okay. And let's graph these. Okay, let's graph. Oh, these are the sum. We have to do the count, sorry. We have to do the count, not the sum. Here we go. This is the count, okay? Now, let's graph these guys. Insert. Good. What is this now? What is the difference between this one and that one? First of all, the one on the left is the, let me change the color for the sake of differentiate. I like that one. Okay. The one on the left is the population distribution. It represents the x values, right? The x values and the frequencies of these x values. However, the one on the right represents what? The sampling distribution. This is not a full sampling distribution. This is just portion. What is the sampling distribution? We take all of the possible samples and we find the average. We find the average of each sample. Then we graph them. We get what's so-called sampling distributions. This is number one. Number two, if you look at both of the distributions, which one looks more normal, more symmetric? The population distribution or the sampling distribution? The population distribution looks kind of a little bit skewed, right? There's a skewness here, right? To the left. But this one looks more symmetric. Where is the mean here? Where is the average? Where is the population average? It's 2.5. Let's go back. Let's look at these guys. Look at these. The population average is 2.5. Where is it? It's 2.5, somewhere in the middle here. So that's why the mean is greater than, look at its, I mean, the mean is here. So it's kind of skewed, right? Yeah, but the question is, so, okay, the first thing we learned is what? This is the sampling distribution. This is what we call is the sampling distribution. Sampling distribution is important. What do we have in the x-axis? In x-axis, we don't have the x values. We have the x bar values. Remember, it's the x bar values, not the x values. It's the mean of the samples. How many samples? All of the samples. But we can control the size here. I said 30, right? So these are all of the samples. It should be all of the samples, but we took only like, how many samples would we take? Like 100, right? If you take all of the samples from this population, it's going to be a really nicely symmetric bell curve distribution. This is the first fact, or two facts. Number one, we talked about the x-axis. The second one, we talked about the shape of the sampling distribution. The other and the third and most important one, because this is kind of symmetric, you can tell me now, the mean is located somewhere here. And yes, it is correct. If we now calculate the mean manually, the mean is going to be between these two numbers, 2.37, 2.57. The mean, listen, the mean of the sampling distribution. The mean of the sampling distribution. What does it mean? Yeah, the average of the averages. The mean of these guys. If I add now, the average. These are the same, but I made kind of a rounding, okay? So the average of the sampling distribution. The average of the sampling distribution, we just find the average of all of these guys. Where is it? Okay, so from here, oops. From here, I guess. Let me make sure that they are. No, still I missed some of the numbers. That's okay. Let's take it up here. Okay. So this is from basically 8, I think 8. It's 2.51, almost approximately. Oops, no, it's 38, sorry, 38, 39. Okay, so this is the average. Okay, it's 2.5, approximately 2.5. And as I said, look at them, 2.5 is here. So the average of the averages, the average of the sampling distribution is 2.5. Let's go back here. This is very nice. What is the population average? It's 2.5. So what do we conclude? The population average is approximately equal to the average of the averages, or the average of the samples, or the average of the sampling distribution. The average of the sampling distribution. These are different names I'm using. And this is very nice, because this is very helpful. Because now we will be jumping from dealing with samples to make decisions about the populations. We will be making some estimation and hypothesis testing using these nice facts. And these are the most important facts. After this, I'm going to make the theory. I'm going to just do a quick presentation using the theory, the theorems, that makes connections about these. Someone's going to ask me, what about the population standard deviation? You did not make connection with this. I will. Let's go back here. What is this? The SD. The SD of the sampling distribution. SD is the standard deviation. STDEV, right? We got 0.23. This one is 1.5, right? Standard deviation. And the question is, what if you did this? What if you did this? What if I take this number and divide this number by the square root of this magic number 30, sample size? What I'm going to get? 0.27. And here we got 0.23. 0.23. 0.27. I just divide this one by the sample size. We got, they're not the same, but they're telling you something. They're telling you, if you continue taking samples, I took only 100 samples. If you take all possible samples, now we took 30. If you take 50, it's going to be better approximation. If you take 70, it's going to be better. Bigger is better. If I take all possible samples from that population, and you calculate the standard deviation here, the standard deviation of the sampling distribution, and if you calculate the standard deviation of the population and divide that one by the square root of the sample size, they're going to be the same. They're going to be what? The same. The last observation I'm going to say is what? Regardless of the population distribution. So suppose that the population distribution, as we see, it's a little bit skewed, right? Regardless of the shape of the population distribution, the sampling distribution is going to be always symmetric if the sample size is large. What is the large? 30 and above. 30 and above. And what is the sampling distribution? All possible samples. I did not take all possible samples. I just took 100 samples. If you remember, we took only 100 samples. If you take all possible samples, it's going to be a really nicely symmetric, bell-curved distribution. So I'm going to make connections now with the theorem and theories and do some examples.